order to perform analysis on this particular solenoid, what I am going to do is I am going to take this steady state thermal and place it on the project schematic, and I am going to engineering data, I am going to engineering data sources, and now I am going to general materials library. In the general materials library, I am going to search for grey cast iron and then polyethylene, and then structural steel is by default applied, so I need not add it once again, and I also need to go for this copper alloy. So once I have selected all the required materials, then I am going to just close this engineering data, and now I am going to just right click on the geometry, say import geometry, and I am going to select browse, and in the browse I am going to select this particular solenoid, and I am going to press open. And once I have imported the required geometry, I am going to double click on the model cell in order to open Ansys Mechanical. So once this particular model is open inside Ansys Mechanical, the first thing is I am going to set up the materials. For the bracket, the material is structural steel. For the core, the material is the cast iron. So for the insulator, the material is polyethylene, and for this coil, the material is the copper alloy. So once I select all the required materials, the next thing I need to do is I need to right click and say generate mesh. And once I generate the mesh, then we are going to apply the boundary conditions. In order to apply the boundary conditions, I am going to right click, say insert, and take this particular internal heat generation option, and I am going to select this core, and I am going to press apply. The magnitude of internal heat generation is 0.01, and I have entered this particular value, and I am right now right click and say insert, go to the temperature, and then I am going to select this particular phase. So in order to select the phase, I need to go to this selection toolbar, select the phase select tool, and then come back and select this phase and say apply, and the temperature is 25 degrees. Then coming to the next boundary condition, I need to insert a convection condition. So I need to select all the top faces. So what happens, the convection is going to take place through this top surfaces, and once I select all these surfaces, I can press apply, and the film coefficient of this particular problem is 5E minus 5 watts per mm square degrees centigrade, and then the ambient temperature value is 25 degrees centigrade. And once I have entered all the required values, now what I am going to do is for this plate, I am going to give a perfectly insulated condition on the other three sides. So that means no heat can enter or no heat can go out through this particular boundary condition. So I am going to select this perfectly insulated boundary condition, and I am going to select this face as well as this face. So once I have selected the three faces, I am going to say apply, and once I have applied all the boundary conditions, I can just right click and say solve. Once I solve this particular problem, I am going to right click, say insert, go to thermal, go to temperature, and I am going to right click and say evaluate all results, and see the maximum temperature is at the core. This particular insulator at the middle is keeping this particular heat from going away to this copper alloy or the copper coil. Then coming to the next stage, we need to create a path, and we need to define a path through which we need to graph the change of or variation of the temperature. For that purpose, what I am going to do is I need to create a path. So as I have shown you earlier that we can select any edge to create a path, here what I am going to do is I am going to create two coordinate systems, and I am going to place a path between origins of those two coordinate systems. For that purpose, I need to go to the coordinate system, say insert coordinate system, and in the coordinate system, instead of defined by geometry selection, I am going to change it to global coordinates, and once I change it to global coordinates, I need to give the values of its origin. So the origin is at 23, 50 and 4 mm. So this is nothing but a point on this particular face. Then I am going to right click, say insert, I am going to create another coordinate system. I am going to define it by global coordinates, and I am going to give the coordinates here. The coordinates are 23, 50 and 38, and once I have created these two coordinate systems, I am going to go to the model branch. I am going to select the construction geometry, and in the construction geometry I am going to select to create a path, and once I select the path, Here in the path type you can just give the starting coordinate system as well as ending coordinate system. So the starting coordinate system is, I'm going to change it from global coordinate system to the coordinate system 1 which I have created now, and then the ending coordinate system also I'm going to change it to coordinate system 2. And now see, a path has been generated between these two sides of the solenoid. Now what I'm going to do is I'm going to plot the temperature along this particular path. I need to go to the solution, say insert, go to thermal, go to temperature, and instead of this geometry selection I'm going to change it to path, and I have created only one path, so in the path I'm going to select that path, and once I have selected that path I'm going to right click, say evaluate all results, and I once evaluate the results, see here a graph has been shown. So what happens, as the length is going this side, the temperature variation is shown here on this particular y-axis. So this is how you can create different paths, and you can plot different values. Even you can apply this technique in the structural analysis as well to plot stresses and strains and other sorts of output which you want or which you require. So this is how you can perform an analysis, a coupled thermal analysis, where two or more different modes of heat transfer may be there using Ansys Workbench. In the next section we are going to deal on how to perform thermostructural analysis on different industrial problems.